Hi everybody, welcome to Module 12, and in Module 12 we're taking a look at Chapter 12, and in Chapter 12 we're looking at networking and security in the business world. And so some of the stuff we've already covered before, so there'll be a little bit of review, which is also another way to say a little bit of reinforcement of things we've already learned. And some of the stuff is new, so we'll go through it and we'll reinforce some stuff we already know through review, and we'll learn a few new things. We're going to take a look at this stuff right here. You can pause the video and you can take a gander at it. And then we're also going to take a look at this stuff right here. And then finally, we'll take a look at that stuff right there. So let's get into it. The first thing we'll talk about are the benefits of a network. And a network gives you two main benefits. And this is a review for us. I think we've talked about this before. But the two main benefits are allows you to share information and share physical resources. Okay, so if you look at everything on this slide here, it's one iteration of that or the other. Sharing information, sharing physical resources. So before networks, we communicated in person, and then we learned to write, and we communicated with writing. And then we invented other ways of communicating. We kept creating inventions to extend this human capability, this human desire to be able to communicate, to share information. One of the benefits of a network, share information. And so those inventions, right, went from writing to the telegraph to the telephone to, I don't know, now everything we do on the web. Video conferencing, videos, all that. So a couple of interesting things to know about sharing information is that when we communicate, we have both asynchronous and synchronous communication. So please explain synchronous communication and asynchronous communication. Okay, and so those are two types of communication. Synchronous means it happens at the same time, and asynchronous means that happens at different times. So synchronous communication would be like a phone call where you're talking in real time, or a video conference where you're talking in real time. You're syncing, right? It's real time. And asynchronous is like this video. I'm recording it at some point in time. You're watching it at some other point in time. That's asynchronous. I'm sending a message and you're consuming that message at a later date, a later time. Another asynchronous communication would be like voicemail. You leave a voicemail and then at like one point in time, and then at some future point in time, somebody consumes that voicemail. That's asynchronous. Email is asynchronous. You send the email, it might be a minute, it might be an hour, it might be a day, it might be a week until somebody gets back to you. Asynchronous, right? And so it's asynchronous communication. There's also synchronous and asynchronous class meetings. And so a synchronous class meeting is you're all meeting at the same time. Asynchronous class meeting is, or an asynchronous class is like, this, where you go and consume the content at whatever time you want to consume it, and I've created it at some previous time. So that's synchronous and asynchronous. And also a good thing to know about when we're talking about communication and networks, and the two benefits of a network are sharing information, sharing physical resources. Another good thing to know is that there's this idea of simplex, half duplex, and full duplex. Okay, please also explain. There we go. And so half duplex, simplex, half duplex, and full duplex are just different ways to kind of talk about communications. And simplex communication is one-way communication. And so like a radio station, that's one-way communication. They're broadcasting to everybody, and there isn't really a way using that medium. There isn't a way for somebody to talk back to the people broadcasting, not unless you choose a different medium, like I'm going to call them up. I'm going to call the station. Now you're using a different medium. You're using a telephone. A telephone is made for synchronous communication, and telephones allow full duplex communication. So full duplex communication means that either person can talk at either time, and those messages just go back and forth. And there could be a collision. Two people could talk at the same time, and their sound could collide. And then, usually humans have rules or protocols that they follow when there's a communication collision, when we're communicating with each other. And those rules and protocols are usually something like, oh, I'm sorry, go ahead. Right? And so that's like, an example of full duplex communication is the telephone. And an example of simplex communication, you can pause the video and you can read about this, An example of simplex communication would be like radio station or like TV broadcast or YouTube videos. It's really one-way communication. Somebody creates a message, puts it out there, and there's no way to communicate back with the person who using that same medium with the person who created the message. So that's simplex. Full duplex is like same time, like telephone calls or video conferences. And then half duplex is like you have communication that could go both ways, but it could only go both ways at one way at one time. So that'd be like a walkie-talkie, right? You could communicate both ways, but you can't communicate both ways at the same time. So like a walkie-talkie, it's like you say something, you're like, hey, I'm over by the rocks, over, right? And then the other person's like, oh, I see you, I'm by the river, over, and you take turns. That's half duplex, okay? So it's like a walkie-talkie. So that's just like some cool stuff to know about networking, some of the terminology. But really the two main benefits of a network: share information, share physical resources. Physical resources be like, hey, I want to print. Everybody in the company, I want them to be able to use this printer. If you're all on a network in the company, they could all use that printer. Those are the two benefits of a network: sharing information and sharing physical resources, right? What are the disadvantages of a network? You know, you're going to have people to take care of it. So having a network, you need people to take care of it. And you're going to need, when you're in a business, and you're going to need special equipment and software. So it's going to cost you some money, but you get all these benefits. So it's, you know, you pay for what you get. And now there's a couple of types of networks. Again, we've talked about these a little bit: a client-server network and peer-to-peer networks. And the interesting words here that have been included in the textbook are centralized and decentralized. So a client-server network is a network where you have like one server. And let me just check here. So here's the server right here. You can see it in this image. And then that server fulfills requests for all of these clients. So these are the three clients. And these clients are connected to the network at a switch. And so these two are connected to this switch wirelessly. So switch, a router, a hub, those terms are all very closely related. But a switch is going to switch. Like if the server says, send this back to laptop number 1, it'll go right there, laptop number 1. Send this to laptop number 3, right? Goes to computer 3. Send this to computer 2. Goes to computer 2. And so those switch will switch, like this goes to this computer. That's what a switch does. And so all these computers are connected to the switch, either with wires, these would be Ethernet cables, or with wireless. They're connected to the switch, and then the server's connected to the switch. So when these computers want to do something, if they want a web page, it goes to the server, and then the server goes to the internet, gets the web page, comes back, gives it back to the client. And the reason businesses want to set that up is so they could control things. They could monitor things. They could see if their employees are going to websites they don't want them to be going to. Or, they can monitor what each employee is doing on their shift. Like, what are they looking at, right? Are they just browsing the web and watching movie trailers and TikTok and YouTube, or are they actually getting work done? So the server allows you to do stuff like monitor that. Also allows you to have security. There's one point in and out of the network, right? So if you want to go to the internet, you have to go through the server, and the server can put in defense to prevent some stuff from coming into the work network, or defenses to prevent some stuff from going out from the work's network, right? And so those servers help control the work, network and provide security and help monitor and all that stuff. And so that's what a server does. This is a client-server setup. And like also if you wanted to print, it'd be like, hey, print this for me. You'd go to the server, and then the server would send it to the printer. And then they can keep track of which employee is printing what stuff. Or, like how much is the printer being used? Do we need another printer? Like all that could be tracked and monitored. And so that's like, the benefit of having a centralized client-server network. And things that are centralized, like client-server networks aren't just like small little things in offices, but also all of Facebook is a client-server network, or all of Google is a client-server network. Anytime anybody is contacting Google or contacting Facebook, they're a client contacting a server, and that server either belongs to Google or Facebook respectively, depending upon who you're going to. And so you could even say that Google and Facebook are centralized, right? Like the center of that network, that client-server network, is like, located within this company. And it might be, different locations all around the world, but still Google or Facebook owns this client server network that is Facebook, where all these clients from around the world can connect Facebook and Facebook servers respond. Facebook owns that. That's centralized. The power of Facebook and all of the traffic of Facebook and anything that's happening on Facebook is all owned by Facebook. It's centralized. Decentralized, on the other hand, is like a network that's not owned by anybody. It's not owned by anybody. And there's not one central location, one government, one company, like one office building where this network is located. So in a peer-to-peer network, it's decentralized. And decentralized is like, file sharing software, or like Bitcoin and cryptocurrency, right? Like there's no one organization, location where Bitcoin is located. It's located on people's computers all over the world. And so you can't really like go and shut it down. Like you could, shut down a few computers, but then it just springs up on other computers elsewhere. And so it's kind of a really powerful thing, having it decentralized. Like governments can't control it. And there's some benefit to that, right? Because if governments get tyrannical and they want to shut things down and not make them, allowed, they can only close off the country to certain stuff. But then, people can still be running it other places, and they could be running it in ways, that maybe are not detectable inside the country where it's been shut off. So those are client-server networks and peer-to-peer networks, and client-server is centralized, peer-to-peer is decentralized. I like thinking of client-server kind of like a restaurant, right? Where in a restaurant you have servers, you have clients. Clients ask for stuff. Hey, will you get me a burger with fries? And then the server goes and fulfills that client's request, comes back and serves that client the burgers and fries. That's kind of like how client-server networks work. Peer-to-peer, it's just like you're helping each other out. Sometimes you're asking another computer for something and they're giving you something. Sometimes somebody else's computer is asking you for something, your computer, and your computer is giving something, serving something back to somebody else's. So peer-to-peer, in some ways, you could say that each computer is sometimes the client and sometimes the server, and there's like a whole bunch of servers all over the place depending upon what's going on. So those are those two types of networks. Advantages of client-server networks, you can see the advantages right there. It's pretty much the model for, centralized organizations, and so there are the advantages. We talked about LANs and WANs. So local area network is a network in a small geographic area, like, just the computers at Fresno City College. A wide area network is many users over a wide physical area. So that'd be like all of State Center Community colleges, like Fresno City College, Reedley College, Clovis College, Madera College, Oakhurst, right? They're all connected with a wide area network over a wide physical area. An intranet is a private network set up by a business, and then an extranet is part of an intranet used by people that are outside the organization or certain people inside the organization. It's an extranet. And organizations will sometimes exchange data with other organizations, and they do that. It's called electronic data interchange, EDI. That's just one of the names, whatever. You don't have to memorize these things. People just randomly made up these names, but you just need to know the idea that, yeah, sometimes organizations exchange data with each other electronically. It's electronic data interchange, close enough. Virtual private networks, we talked about them a little bit before, so it's a little bit of review. Allows you to establish a secure connection between you and another location. So those could be used like if you want more anonymity and security when you're browsing the web, you could use a VPN. But also, you could use a VPN to connect one office with another office and create a secure tunnel, which is just like encrypted, transit of data between the two locations, and that can be referred to as tunneling. Client-server networks have key components, which is all of this stuff. They're going to need servers. They're going to have network topologies and ring topology as opposed to bus, star topology as opposed to bus, and ring is the most popular topology. Hold on one second. I'll find the little chat GPT that I did on this in class. Wait one sec. Let me go get it. All right, here's the stuff we did in class today. So first we talked about simplex, half duplex, full duplex, and then we looked at like decentralized Bitcoin and how much electricity does Bitcoin take. It's the same amount of electricity as the entire country of Norway globally, and that's 5.5 million people, so that's how much electricity Bitcoin's using. And then Bitcoin being decentralized, we talked about that in class, so you could read through that. and characteristics of Bitcoin's peer-to-peer network. You can pause the video and you could read that. And then we talked about Bitcoin and the power law, because it became a topic of conversation in class. So you could pause this and read about the power law, which is kind of interesting. And then we also talked about the number of addresses in Bitcoin, and could the top 2% have a collusion, or could they collude to influence the price? And then we also talked about characteristics of collusion, what that was. So you could pause the video and you could read about characteristics of collusion. And then we took a look at how do you innovate, like, Bitcoin is an innovation, and we looked at like how many people are stuck in traffic and thought about innovating in traffic. And it's 7.7% of Americans commute more than an hour each way each day, which is 157 million people. It's 12.1 million people commute more than 1 hour a day in America. And so we calculated what the economic cost of that is at $30 an hour. So for an entire year, it's $174 billion, which is like a lot of money. If you can figure out how to keep people from commuting an hour every day, you're recovering that amount of money. And then we talked about client-server network key components. So here we looked at servers and we looked at network topology. And so I just told you about star topology right here. So you could pause the video and read those things. And then we talked about transmission media. So this was everything related to this: servers, network topologies, transmission media. And with servers, I used to think that servers were like, a special type of computer, but they're just computers, usually more powerful, that are running specialized software so that they can manage the network and do everything servers do, like I explained just previously. And then the topology is the physical layout of the network, and we're going to see slides on that here coming up in a second, but you can pause the video and read this. And then the transmission media. When I think of media, I think of pictures or videos, but media here is really referring to medium, and media, I guess, is plural of medium, so it's just confusing. But like, what is the medium that's being used to transmit your data? You could use a wire, or you could do it wirelessly. So we've talked about that too. And wired is like, Ethernet or coaxial cables or fiber optic. And wireless is like Wi-Fi or Bluetooth. And then network adapters, again, we're just going through these components here. Right here, we're looking at network adapters. Network adapters are the component inside of a computer that lets the computer connect to the network. They're also referred to as network interface cards, or NICs. And so that's what network adapters are. And then we have network navigation devices. And so this is kind of just a funny phrase, network navigation devices, but it allows, like, how does data navigate the network? And these devices help data navigate the network. So router, switches, and hubs. And so a router is going to direct traffic between different networks, such as the internet and local networks. It chooses the route the data travels on. How do I get to the destination? So every piece of information that you put onto the network, it has an address where it's going. It's like the mail system, right? Like the postal system in America. So you want to mail a letter, you put an address on it, you throw it in a mailbox, and then the letter ends up wherever the destination was. And there's an entire system to get the letter to the destination that was written on the envelope. Same thing with these digital networks, right? So if you're going to send something, an email or a text message, that gets broken into a little packet. In the postal system, we call it an envelope. In computer networks, we call it a packet. That packet gets an address put on it, gets thrown on the network, and then these routers read the address and they're like, oh, you're going there. Why don't you take that route, right? And the router chooses the route for that packet to go. And then it might come up to another router, and the router's like, oh, you're going there? Go this way, right? But the routers help figure out what route these packets with addresses on them need to take to end up where they're going. Those are routers. A switch is like in that one picture we saw here previously, right? Like, go to computer 2. It's like, okay, computer 2 right there, right? And you can see computer 2 right there. Go to computer 1. Okay, computer 1 right there. Switch, like, is more a local network where it's choosing, local network, right? Choosing which computer data goes to. And then a hub connects multiple devices and network, but it doesn't manage the data traffic as efficiently as switches. That's a good way to describe it. And then we have network operating systems. So when you have a network, you need to have operating systems on the computers on that network. and that helps manage the network and resources and user accounts and data and securities, and includes functionalities for file sharing, printing, network traffic control, user authentication, resource allocation, Windows Server, Linux-based servers, Ubuntu servers, macOS servers, Unix-based systems. Those are all examples of networks. That's it for this slide. Next slide. We talked about LANs, and we talked about WANs and Intranet and Extranet. Oh, because we went back slide. Here we have just a picture of what networks look like. So here's an example of a VPN tunnel. And so you have one office in Denver, Colorado. You have one office in Phoenix. And you have a secure encrypted virtual private network between these two offices. So data could travel over the internet in an encrypted way. That's what that picture is showing you. A dedicated server fulfills a specific function, and there could be print servers and application servers that allow you to run applications from that server within your organization, and database servers and authentication servers and file servers that allow you to get files or serve files, and email servers and communication servers and web cloud servers, right? So these are dedicated servers, and here's a slide that gives you a little bit more detail about each of them, and you can just pause the video and read about there. Next thing we're going to talk about is virtualization. And so if you remember when we talked about like hardware and software and the interrelationship, I had this little picture where we had hardware, and then on top of hardware is your operating system, and then on top of your operating system is your application software, right? And so that is your stack and its layers. And this hardware is specific hardware. It's either like Apple hardware or it's like Windows compatible hardware that's running like, you know, Windows chips. And those are different CPUs with different instruction sets. So you have to create an operating system to run on that hardware and take advantage of that hardware. And then after that, you install your application software on top of the operating system, and the application software has to be built for that operating system. So the OS is built for specific hardware, and then app software is built for a specific OS. So that's the normal stack. With virtualization, right, on one piece of hardware, because maybe you have this installed on that hardware there. So you have this hardware here, right? And you have this stuff here installed on that hardware. And we'll just choose a different color, right? And we're going to abbreviate this as OS, and we're going to abbreviate that as app, okay? 2, right? So that's your setup. And I'm actually going to like copy this, cut it, and I'm going to bring this up here, and I'm going to go up to here. I'm going to choose insert and a table, and I'm going to do like that. And I'm going to bring this over and bring it down, and then I'm just going to merge these together. I think if I right click I could merge cells somewhere here, merge cells. And so, you know, your normal setup is like this, right? Merge cells, merge cells. So you have your hardware, and then you have your OS, and then you have your apps, okay? That's your normal setup. And so let's say you have that set up and it's using 20% of the computer. So somebody's like, well, hey, let's create like little safe spaces for, you know, different stuff to run and use up more of that processing power. So this is only using 80% or 20% of the computer. So here's the hardware. And now let's install one OS here. And let's install another OS here and another OS here. And maybe here we have Windows, and maybe here we have Linux, and then maybe here we have like, you know, older Windows. Or we have different operating systems there, okay? And then up here we would have apps and apps and apps. And so each of these here, right? Each of these here are running on this hardware. And now we have 100%. So here like only 20% of the hardware was being used. And now here we have 100% of the hardware being used because there's just more processing going on. So, you know, if we're paying for a computer, let's use 100% of that processing that is available there, as opposed to buying 3 computers, right? And they're each using 33%. Let's buy one computer and use 33%, 33%, 33% for each of these things. Now we're maximizing, you know, this resource that we bought. We're actually making it work to its full capacity. That is virtualization, okay? So virtualization. It's one hardware, and you got different things running on it, and it could even have different operating systems. The problem with this is that, I'm just going to make this smaller. Come on, get smaller. Get smaller, man. Get smaller. Okay, there we go. The problem with this configuration is that there's a lot of overhead with operating systems. So that was using up a lot of the resources on a computer. So somebody else came along and said, well, how about if we do this? I'm going to insert a row above. I'm going to insert a row above. And they said, all right, this is going to be one row. So we're going to merge that, and we're just going to call it OS, okay? Whoops. OS. There we go. And I'm going to get rid of this. I can't get rid of that. I have to go up to Slide, Edit Theme, go to this one, and get rid of that. Come on. Go on. Go on. Boop. Get rid of that. Get rid of that. All right. And then close that. It should be gone. There we go. Perfect. So, so they said, all right, let's put the hardware here. Let's put the operating system here. And then here, let's run Docker. And they created this software called Docker. And so here is Docker. Docker is not public, but here's Docker. So Docker is container application development, okay? So it's Docker. And you can pause the video and you can read about that. And with Docker, you have the hardware, then you have an operating system, and then you run this Docker layer, and then you have containers above it, where your containers could like be completely configured as if they have an operating system and whatever application software is running on that. But you create these containers, and you can run as many containers as you want, and they can move between computers with Docker on them easily. So it just allows networks to take advantage of the full processing capability of every single computer that they have. And it makes it easier for developers. And this is lower resource demand than this, right? Having this here is lower resource demand than having these. It's much more efficient. So it's a better use of your hardware. And so they created this kind of a layer. And this is all like virtualization, those parts there. And this is also known as virtualization here, right? The Docker with the different containers running on Docker. So that's just interesting stuff, right, to think about. But virtualization, if we went to ChatGPT and we said explain virtualization, I'm just looking to see if we went for that. What is traditional virtualization? You can pause video and you could read about it here. And you could also read my question there, right? And you could also read Docker and containerization right there. And you could see how Docker improved traditional virtualization right there. All good stuff to know about. All right, moving on. Ready? Let's do it. Because it's late for me at 9:22. I want to get this done and get to bed at a reasonable time. So now we're going to talk about topology. We already visited this. And bus topology is everything's on one line. The problem with this is if you cut it, the network goes down. So you can read the advantages and disadvantages right here. And then we have ring topology, and ring topology looks like this. You have everything connected to a ring. And if it gets broken, well, data could still go this way and the network could stay up. Here are the advantages and disadvantages of a ring. And then we have star topology, and star topology looks like this. You have a switch in the middle, and everything's connected to that switch, okay? So here is the server. And it's like the image we saw before, but there's more stuff connected this time. And if somebody cuts their cable or kicks their cable out of the wall, it's only going to affect their computer. The rest of the network's fine. So this is really the most popular method. Star topology with a client-server network is the most popular way to put together a network. And here is info about star topology and also the advantages and disadvantages of a star topology. When you put together a network, you have to think, or people who create networks think about when their communication collisions. So I gave you that example of humans communicating, and we have protocols or rules that we use when we're communicating. And those protocols and rules are like, one person talks and everybody else listens, and then when that person stops talking, other people talk. That's actually a really subtle and nuanced thing, because people have a way of just like it's second nature to them, where, yeah, I get you, and they know right when to come in with others. And it seems like a lot of people know how to do that. I'm not one of them, right? Like for me, it's like it's hard to kind of like communicate with people, and so some people are just born that way. I'm one of them, and it's kind of like the analogy is like if you learn Chinese, like you got a whole layer of additional processing if you learn Chinese later in life that you're doing as opposed to just communicating, right? You're like like your brain's working in ways that people who just natively know that thing, their brain's not working. It's not second nature. So that's kind of an interesting thing. But point being, when people communicate, there's rules of communication, there are protocols. And those protocols, one of the things, it helps manage collision. So when people talk at the same time, if they both start talking at the same time, oh, I'm sorry, you go, right? We have a way to manage that collision. Same thing on a network. If like two computers start sending something on the network at the same time and the data, collides on the network, so it's like not, clear who sent what, it kind of gets jumbled. They can resolve those collisions. That's what this is here, right? That stuff right there. That is your star topology, and then transmission media, wired and wireless. We've talked about those before, and factors to think about when you're choosing different cables, and how there could also be interference with the transmission stuff. And the next one is like additional things to think about when choosing what kind of cables or wireless connections you're using. How far can the cables run? How much bandwidth, how much data could go over that medium? How flexible are the cables? What's it cost? What's the installation cost? Is there any interference, like data's gonna like get jumbled going over the cables? So there's twisted pair like Ethernet. You can pause the video and read this. We've already talked about. It's just a type of cable. It's the most common one, Ethernet, and Ethernet is twisted pair. And that's what's used. It's sometimes called Cat6 or Cat7 or Cat something, whatever number they're at now. But that's how most networks are connected with wires, is with Ethernet within buildings. And then you have coaxial. This is like what your internet connection comes into your house on often. And then there's fiber optic, which is the fastest because it's light, it's sending light. And then you have wireless connections. And then we have network adapters, which it's the hardware component inside computers that allows them to connect to networks. And then you also, here's a picture of a network adapter, network interface card. Those terms are interchangeable, right? And kind of how communication occurs. I have no idea why my mouse is jumping around so much. How communication occurs, there it is. Like step 1, step 2, step 3, step 4, you could read that. So what else do we have here, ladies and gentlemen? So we've got, just another picture of a network here, and things connect to the network. And then every computer has a MAC address. And so this is kind of like a social security number, uniquely identified, just like your social security number uniquely identifies, or a social security number uniquely identifies every American. MAC address uniquely identifies every computer. And when you go onto a network, it can know which computer is connecting because it can look at what is that MAC address. We talked about a switch, right? And we also talked about routers, and we're not worrying about bridges. And then a network operating system is, it's the operating system to run a network, and needs to be installed on each client, each server computer. And the network operating system facilitates communication, and TCP/IP is a standard network protocol. And sources of security threats in networks are human errors and mistakes, malicious human activity, natural events and disasters. The entire network can be destroyed. And authentication is used to screen users. So different types of authentication. And then we have, we'll talk about those in a second. Then we have brute force attacks, which they just try every possible combination of letters and numbers and characters to try to guess people's passwords. That's a brute force attack. And then, so to access a network, you have these 3 ways to authenticate people. Something they have, like a key, something they are, like their thumbprint, or something they know, like a password. And you could choose 2 or more of these for multi-factor authentication. Firewalls are like, ways for businesses to protect what's coming in, or, some organization, even a country. And it's composed of software and hardware. And it screens for packets, you know, to make sure that what comes in should come in, what shouldn't come in doesn't. And you know, yeah, so that's what a firewall is. And so here's a visual picture of that. And we'll go to ChatGPT and just ask it, can you please explain firewalls in basic terms? And we'll do this computer firewalls in basic terms. Let's see what it says. Computer firewall acts like a security guard for your network computer, helping to keep unwanted traffic out and allowing trusted traffic in. Think of it as a protective barrier between your computer and the internet. Firewall is a piece of software or hardware that monitors and controls incoming and outgoing network traffic. It's designed to block unauthorized access while allowing authorized communication. Firewalls use a set of rules to decide whether to allow or block data packets, small pieces of information. When you're connected to the internet, data constantly travels to and from your computer. The firewall checks this data, decides whether it's safe or not based on its rules. A firewall protects your computer and network from hackers, malware, and other threats that might try to access your system. It keeps your personal information, like passwords and financial data, more secure by blocking suspicious activity. Firewalls installed on individual devices, that's software firewalls. And then how firewalls help. Imagine you're having a party at home. You'd only let people you know and trust, let in people you know and trust while keeping strangers or unwanted guests out. Similarly, a firewall lets in good data, like a website you want to visit, but blocks bad data, like a hacker trying to access your computer. So that's a pretty good basic definition of a firewall. That is chapter 12, ladies and gentlemen. I hope you enjoyed it. Have a great day wherever you are. Whatever you're doing, count your blessings. Keep a positive attitude. Put time in each day working towards your goals and growing your knowledge and your skills, and you will progress in life. You will. Just keep going to school. Degrees get dollars, and this is a unique and rare opportunity that you have right now at this point in your life to choose your paycheck, right? Meaning you get to choose what career you're going into. Do you want to be an ER doctor? Do you want to be, you know, a pilot? Right? You get to choose your career, which is also choosing your paycheck. And so make a good choice. Choose something which is going to be around in this era of AI, and choose something that pays you well so you can provide for yourself and your family. Have a great day and stay positive and keep working and keep going to school, and you'll end up in good places. See you next time.